Hi, in this video we'll be talking about sorting lists. We'll be using the sort method and the built-in sorted function. One thing to keep in mind right from the beginning, unlike in older versions of Python, we only can sort lists with all the elements of the same type. It is now impossible to sort lists with heterogeneous elements. This is what happens if we try. Here we have a list with strings, integers, floats, well, different types of data. Let's use the sort method to sort this list. As you can see, we're getting an error. Comparison not supported between instances of integer and string. But still, we can sort lists with different types of numeric values, like ints and floats, but not complex numbers. Have a look. Here we have a list of numbers. Here we have 2 integers and 3 floats. Here, here, and here. This is also a float. This is in scientific notation and it just means 3.4 times 10 to the power of negative 8. And now let's try to sort this list and print it. Fine. As you can see, this list has been sorted correctly. We can even use the Boolean literals true and false. They are treated as 1 and 0 respectively. So, here's another list. Here we have integers, floats, here and here. And these are Boolean values, Boolean literals, which actually are treated as integers. This is 1 and this is 0. So we can sort this list like so. Let's print it out. Yeah. So here is false, which is 0. And then we have the numbers in ascending order. This is 1, this is 2, and so on. And here's how a list of lists gets sorted. So a list with nested lists, like so. The elements are compared in the order they're in. So let's sort this list and print it out. Fine. So here we have 3, and 3, 4. So first, the first elements are compared. Then the second elements are compared, then the third, and so on. How about a list of strings? Have a look at this. Here we have some short strings in the list, and let's sort the list. And here's our list after sorting. Well, the characters are compared one by one. Capital letters come before small letters. And if there are digits, they come before capital letters. So the order is digits, then capital letters, and finally small letters. Hence the order. Well, note that in strings, the individual digits are compared one by one, not the values of the numbers. Have a look at this. Here we have a list of 3 strings. These look like numbers, but they are in quotes, so these are strings. Now let's sort this list and let's print it out. Fine, so here we have 10, 101, 11. This is because first these elements are compared, they are all the same, then the second elements are compared. So 0, 0, and here we have 1. And this is why this is before this when treated as strings. And here's another example. Let's sort this list. As capital letters come before small letters, can is last instead of first. but we can pass a keyword argument called key and set it to str.caseFold if we don't want the case to matter. Have a look at this. First, let's reset our list of strings. And now let's sort our list. And let's pass the key argument and set it to str caseFold. Now we can print our list, and it turns out that now the casing doesn't matter. Alternatively, you can set key to str lower or str upper so that the characters are converted to all lowercase or all uppercase respectively before they are compared. This conversion is used by the sort function, but it doesn't permanently modify the strings in the list. So let's try it out. Here's our list again. Now we can sort the list and pass the key argument and set it to str lower. So now the sort method is sorting according to this key. So before comparing the strings, they are all converted to lowercase. Now let's print our list. As you can see, in the original list, the casing hasn't changed. Or we can use the str upper key, like this. Here's our list again. List sort key equals str upper. And here's our list. Sorted, but the casing is not changed. You can also use the key with a lambda expression. So first let's reset our list again. And now let's sort it using the key argument again. And let's set it to a lambda expression like so. Lambda x lower. And here's our list. You can assign a built-in function to key as well. Here's how we can use the len function to sort the strings from shortest to longest. So here's our list, from to, between, for, opposite, under. And now we want to sort this list not alphabetically, but from shortest to longest. So let's use the sort method like so. Our key is the len function. Let's print our list, and here it is, from shortest to longest. And now a more complicated example. Suppose we want to sort the strings by the last character. We can define a function that returns the last character and assign it to the key argument. So first let's define the function def last character return as with the index of -1. Just to remind you, the index of -1 is the index at the end of the string. So now, here we have our list. And now we want to sort this list by the last character. Here, here, here. So this is what interests us now. And now we can use the sort method again and set the key to our last character function. And let's print our list. As you can see, it's now sorted by the last character A, D, E, L, O, and so on. As you can see, it's up to you how you sort the elements of your list. Up to now, we've been using ascending order. If you want to sort your list in descending order, you should set the value of the reverse keyword argument to true. Here we have a list of numbers, very simple one. And now we can sort it like so. reverse. This is our keyword argument, and it should be set to true. And now here is our sorted list. As you can see, from 11 to 2. And now a short exercise. We have a list of 3 tuples, coordinates. The 3 values in each tuple are the x, y, and z coordinates in 3-dimensional space. We want to sort the coordinates by the y coordinate, the one in the middle, at index 1. And we want to sort it in descending order. Okay, so we could define a function and assign it to the key argument, but instead we'll use a lambda expression. And here is the solution. Coordinates sort key equals lambda tup. We have here one argument, tup. And now I want to sort by the element at index 1. And we want to sort in reverse order. So reverse equals true. Let's print our coordinates list now after the sorting is finished. And here we got it. 5, 3, 2, 1. So we can see that it's now sorted by the second element in descending order. When we use the sort function, the list is changed in place. The sort function modifies the list, but it returns none. So we shouldn't use it in an assignment like this. Here we have a list, and we want to assign the sorted version of the list to our original list. And this is what we shouldn't be doing, because what happens now? What we get is not another list. This function returns none. So let's check the type of our list. Well, is it still a list? No, it's a none type. So as you can see, all you have achieved by assigning the result of the sort method to the list is that you lost the reference to the list. Instead, the list is now of type none. But it's also possible to sort a list without changing it in place. To this end, we can use the built-in sorted function and pass the list as an argument to it. Let's rewrite the previous example using the sorted function. Here we have the list. Now let's use the sorted function and pass our list as the argument. So here we have the list sorted, and our original list is untouched. So this time the original list is not modified. We can assign the result of the sorted function to a variable, and so we can save the sorted list without modifying the original one. Let's have a look at the following example. Here we have a list of numbers. Now let's create another list called nums ASC for ascending order, and let's assign the sorted list to it. Sorted nums. Let's print our nums ASC list. As you can see, we have the elements in sorted order, in ascending order. We can also define another list, nums DESC for descending order, equal to sorted nums, and let's set the reverse keyword argument to true. And now let's print our nums descending order list. As you can see, it works from highest to lowest. And now let's print our original nums list, and as you can see, it's still untouched. In the sorted function, we can also set the key argument to a function and so determine how the sorting should be performed. Here's an example, a slightly tougher one. We have a list of friends, like so. The list contains descriptions of our friends. The last but one word in each description is a first name. Jim, Jane, Mike, Sarah, Frankie. Using the sorted function, we want to sort the list by first names. Here's how we can do it with a function defined beforehand. So let's define our function. First name, description, return, description, split with index -2. So how does this function work? Well, it takes one parameter, description, which is each of the following strings, here, and here, and here, and so on. It splits the string into separate words, because if we don't pass any argument to the split method, then the white spaces are where the splitting occurs. The white spaces are not included. So after splitting the first string, for example, we get a list of 3 strings, Old, Jim, and Brown. Here we get a list of 7 strings. And now -2 means take the element second from the last, second from the right. So this is -1, -2, -1, -2. And we want the index -2 because we want to get at the first names, here, here, and so on. And now we can use the sorted function like so. Sorted. Here we can pass our list of friends. And then we can set our key argument to our first name function. Enter. And here we get it. Amazing Frankie Jackson, pretty but not too smart Jane Smith, old Jim Brown, silly Mike Lee, my little Sarah Dubois. As you can see, the first names are now sorted in alphabetical order. F, J, J-A, J-I, M, S. And the same with the lambda. So instead of using this function, we can just use a lambda, like so. Sorted, friends, key equals lambda, n, split, index -2. It's even simpler this way. And we get the same. As you can see, you can compare these 2 lists of strings now. And naturally, our original list of friends is not changed. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.